Hello everyone, welcome to my YouTube class. In this video we are going to talk about how do we replace all the prime numbers of the array by 1 and non-prime numbers by 0. And we know that 1 and 0 are neither prime nor composite and prime numbers are greater than or equal to 2. Negative numbers does not belong to the set of prime numbers. Now let us see over here 29. Now we know that 29 is a prime, therefore we will replace 29 by 1. Now go to the next element. That means we have to take each element of the array and check if the number is prime or not prime. Now 27 is prime, therefore we will replace 27 by 0. 25 is prime, therefore we replace 25 by 0. Now 1 is neither prime nor composite, therefore we can do something like if a number is neither prime nor composite, we will replace it by minus 99. We will replace it by minus 99. Now if the number is prime, we will replace it by 1. If the number is neither prime nor composite, because minus 3 does not belongs into the set of prime numbers, what we do? We replace it by minus 99. Therefore, the original array has to be modified. Wherever there is prime, you replace by 1. If the number is non-prime, you replace it by 0. And if the number is neither prime nor composite, like 1, minus 3, 0, any negative numbers, we replace it by minus 99. I hope you understood this question. I want you to pause the video and try to write the solution yourself. Thank you. Let us see how do we write the code for it. Say hash include stdio.h and write all the prototypes whatever are necessary. Let me start with int main. Now what is the input for this question? The input for this question, we need an array of n elements. Let's declare an array and I say int a of 1000. Now what will happen? An array a will be created where maximum of 1000 elements can be stored, and this is it in the main scope. This is in the main scope. This is the main scope, and we have 1000 elements, and we have 1000 elements 0, 1, 2, 3, 4, 5 and so on up to 999. Is that okay? Let the array name be say A is the array name, and let the starting address be say 1000. This is 1004, 8, 12, 16, 20 and so on and so on. Now what is the maximum elements that we want to store? It is 1000. We can store less than or equal to 1000, and let us declare a variable called as n. Now n represents how many elements that we want to store in this array. If the value of n is 10, we want to store 10 elements in the array. If the value of n is 100, we want to store 100 elements in the array, and so on. Hence we read the value of n. We say scanf %d %n. Okay. Now let the value of n be say 6. That means we want to read 6 elements. And what are the 6 elements that we want to read? From in a of 0, a of 1, so on up to a of 5. How do we read the array? We call one function called as read array. Already I have written it. Which array we want to read it? Array A we want to read it. And how many array elements are there? There are n array elements. Particularly write the prototype correspondingly and define the function read array. Now assume that we are reading over here 29, 27, 25, 1, 2 and minus 3. 1, 2 and minus 3. Okay, now instead of 27, let me take it as 0 as well, so that you understand what we do with each of non-prime or non-composite numbers. Now after this, we want to replace it. Let us write one function called as replace. Let us write one function called as replace. In which array we want to replace it? In array A. And how many array elements are there? There are n array elements, and there are n array elements. You have to write the prototype for the replace. I am going to write the implementation for the replace, how we are going to implement it. Now what is the function name? The function name is, I say void replace. If I want to change, I will change the prototype later. As of now, let it be void. What is the first parameter over here? The first parameter is A. It is integer one dimensional array. Therefore, you can write integer one dimensional array this way, or you can write it as what? Int star a, or you can write it as int star a, because we know that the array name gives the base address and address can be stored in a pointer. You can say int star a or int a of, and the second parameter is integer n, and the second parameter is integer n. Now what happens whenever you call the function? The scope of the function gets activated. Now this is the scope of the replace function. This is the scope of the replace function. How many parameters are there? There are two parameters, a and n. Now let me draw the two parameters here, a and n. Let the address of this be say 8000 and let the address of this be say 9000. Now what happens whenever arrays are passed to the functions? The base address gets passed, not the complete array. Now what is the base address here? The base address is 1000 and the value of n is 6, and the value of n is 6. What we should do now? We should take each element of the array, check if it is prime. If it is prime, replace that element by 1, and if it is not prime, replace that element by 0, and if the number is neither prime nor composite, replace that element by -99. Now how do we take each element of the array? We say for I is equal 0. How many elements are there? I less than n, I plus plus. Now if the value of I is 0 in this function, what does a of 0 will give me? Can anyone say? What is a of I? A of I is equal star a plus I. Already I said it. Now this is a is a pointer, it is a address, because array name gives the address. Address plus integer, the scaling factors, the pointer arithmetic will happen, and the compiler internally converts to star a plus I into d, where d is the size of array data type. Where d is the size of array data type. We know this. Now what we do? I take a of I. Now the value of a of I. What does the compiler converts internally? The value of I is 0 and the value of a over here is 1000. 1000 plus 0 into 4. And what is 1000 plus 0 into 4? It is 1000. It is star 1000. It is star 1000. And what is star 1000? Go to address 1000 and fetch the value. What is the value at address 1000? 29. That means I want to check 25 is prime or not. Already in the previous video I have written one function called as is prime. I want you to write down this function yourself. Is prime. Now is prime of a of 0. A of 0 is nothing but star 1000, which is 29. That means this value is replaced by 29 and you want to check that 29 is prime or not. Now what does this is prime function will give you? It will give you answer as 1 if the number is prime, and it will give you answer as 0 if the number is not prime. Therefore what it will return? It will return the answer as 1, and let me store it in some variable p. Now what will be the value of p? What will be the value of p? The value of p will be 1. Now if the value of p is 1, what shall I do? If the value of p is 1, what shall I do? I have to replace this 29 by 1. I have to replace this 29 by 1. And how do I write? I say a of I is equal to 1. There is other way of better way of writing it, but let it be a of I is equal to 1. Now what is a of I? A of I is nothing but star 1000. Already have worked it. Therefore it says star 1000 is equal to 1. And what does it mean? Whenever star, the dereference operator, is on LHS of equation, it means go to address 1000 and store 1. And where is address 1000? It is in the main scope. It is in the main scope. It has stored 1. I hope you are understanding it. Now next you say I plus plus. The value of I will become 1. 1 less than 6. Yes, 1 is less than 6. And what is a of 1? It is star 1000 plus 1 into 4. And what is 1000 plus 1 into 4? It is 1004. And what is star 1004? It is 0. Now do I need to check that 0 is prime or not? No, I need not check that 0 is prime or not. Therefore, how I am going to write this? Therefore, how I am going to write this? Is that okay? Okay, let us see how we are going to write this. Let me just take some space for writing this. How you are going to write this? You check if a of I is less than or equal to 1, That means such numbers are neither prime nor composite. Then what do you write it over here? A of I is equal to minus 99. A of I is equal to minus 99. Now what is A of I? The value of I is 1. And what is A of 1? A of 1 is star 1004. And what is star 1004? It is 0 because this is 1004, 1008, 1012, 1016, 1020. 1004 is 0. 0 less than or equal to 1 is true. Now this is star 1004. And what you are saying? You are saying star 1004 is equal to minus 99. It means go to address 1004 and you store minus 99. And you store minus 99. Now, since you have stored minus 99, do you want to check that it is prime or not? No, we do not want to check that it is prime or not. Therefore, I write an else statement. I write an else statement. Now, since the body of if has got executed, else should not be executing it. Again, you say I plus plus, the value of I will become 2. Now, what is A of 2? A of 2 is star 1000 plus 2 into 4 is nothing but star 1008. We are in replace scope, please here. Now star 1008 is 25. 25 less than or equal to 1 is false. Else part should be executed. P is equal to is prime of star 1008. And what is star 1008? 25. Now is prime of 25 is false. Therefore the value of P will be 0. And you are saying if P equal 1. Is the value of P is equal to 1? No. Therefore, we say else. And what shall I write over here? A of I is equal 0. Hence, we say A of I is equal 0. Now, what is A of I? Star 1008 is equal 0. That means go to address 1008 and store 0. Next again I plus plus, the value of I will be 3. A of 3 is 1. 1 less than or equal to 1 is true. And then star 1012 is equal minus 99. You have to do it according to the steps. I plus plus 4. 4 less than or equal 4 less than 6 is true. A of 4 is 2. 2 less than or equal to 1 is false. You come to the else part and you say is a prime of 2. Yes, 2 is a prime. Therefore, the value of P will be 1. 1 equal 1 is true. Hence, you store 1 over here. Hence, you store 1 over here. Again, you say I plus plus, I becomes 5. 5 less than 6 is true. A of 5 is minus 3 less than or equal to 1 is true. And you say you have to replace this by minus 99. Do not execute else. Again, I plus plus 6. 6 less than 6 is false. You come out. Closing bracket of the function is taken as return. The scope of replace gets deactivated. You come back to main and you see that the array is modified. Why the array is modified? Because arrays are passed to the functions by address. Any changes done in the called function will be reflected back in the calling function. Now you can write int star a, or you can write it this way as well, int a of this particular parameter. Now I come back to main. I see that the values are changed. How do I verify that the values are changed? Yes, how do I verify that the values are changed? We call the display array function. Which function we are calling? We call the display array function. Which array I want to display it? Array A. And how many array elements are there? There are n array elements are there. It will display 1, minus 99, 0, minus 99, 1, minus 99. 1 means that was prime number there. 0 means that was not prime number there. And minus 99 means it can be either 1, 0 or any negative number. And here I write here return 0, and whenever I return it, the scope of the main also deactivates and the program stops. This is how you replace the value of a prime number with 1 and else with 0. Now you may pause the video over here and write the appropriate code. Now how do I write it in a better way? Now here, if the value of P is 1, I am writing 1. If the value of P is 0, I am writing 0. That means in general, what I am writing over here? In general, I am writing P. Now, if P is 1, you are writing 1. If P is 0, you are writing 0. See here, if the condition is true, you are executing A of I equal P, and if the condition is false, then also you are executing A of I equal P. That means this A of I equal P is independent of the condition. Hence, what I can write over here? I can directly write a of I is equal p. Suppose a of I is 29. 29 is a prime number. Prime number means the value of p will be 1. A of 0 is equal 1. Suppose this is 10. A of 2 is an example. Now that means it's not a prime number. The value of p will be 0 and you say a of 2 is equal 0, and you have to declare all the undeclared variables in the replace functions like I, p and any other variable that is undeclared. This is the way we replace each and every element with minus 99 and 0. Now what I am doing over here, can we write in another better way? Yes. Now what did I say? A of I is equal p, and what is p is equal to? E is the prime of a of I. That means directly I can write, what I can write directly, can anyone say? Directly I can write a of I is equal to E's prime. Suppose the number is 29, a of 0 is 29. E's prime function will give you 1 as answer, and you are storing 1 in a of 0. This is the easiest way of writing this code, and you have to implement the function E's prime, which I already did. Okay, I hope you have understood this video. Thank you friends for watching this. You may pause the video over here and make the appropriate notes. Thank you.